is equal to 1 cubic meter. So just the reciprocal.
So tenths,
Point something.
0.25.
Yep. So that extra quarter of me. So a little over 10, so congratulations for those who saw that. So it would take 10 of me to fit inside there. And a little bit. Right.
Really?
Yeah,
I felt like it would have been more. Cubic meter, right?
right.
Hmm.
You would think more of me could fit in there?
I don't know. I'm having a hard time visualizing it. Well, if you're,
That's whole. Right there.
because like your volume is like 0.09 cubic meter.
Right. So when liquefied, I would come up to
I think that's what's going on.
somewhere around there.
Oh, okay.
So from there down, that would be me completely pureed.
Okay, I see that.
All right, the next adventure with density, a little less morbid. More of just fun with Facebook. There was a hurricane off the coast of North Carolina in 99 or 2000, I think it was 99, it basically stalled. So my brother on Facebook wrote that they were getting hit by a ton of rain. So I began to wonder, how much is a ton of rain? So first off, how much is a ton?
£1,000.
You said 1,000? No,
2,000.
yeah, 2,000. So 2,000 pounds of rain. So let's figure out how much that is. So this time we're going to, so first we need to get it into newtons. So 4.448 newtons per pound. Pounds will cancel out. And so I'm left with 6. Is that right? 8896? Okay. So that is equal to the weight in newtons, and that's going to be equal to mg. So the mass would be 8896 divided by, we'll just go with 9.8. We're not talking about Winston-Salem at this point. All right, so this is the mass my brother's claiming that the North Carolina coast is getting hit by. Let's figure out how much volume that is. Well, I know what the density of water is. So we'd have 1,000 is equal to the mass, 907.75, divided by the volume. Units?
Cubic meters?
Yep. Going back over to our cubic meter over here. So during this hurricane that sails off the coast of North Carolina, he says that they're getting hit by rain that would basically fill up to about here. It's about 3 bathtubs. So of course, as a brother, I said, that's about 3 bathtubs worth of water. So what you're saying is they're getting a light sprinkling. Who's done with love? All right, any other questions about density at the moment?
Where'd you get the, 8,896
A ton is 2,000 pounds, and then converted it, multiplied times 4.448, and that's where that comes from. I do want to differentiate the word ton. So TON is 2,000 pounds. And I think part of what Taylor probably was channeling there, there's another word, TONNE, which some people will pronounce tunny, and I always pronounce ton, sort of extending the N. This is a metric unit of mass. This is 1,000 kilograms. Recognize that a ton, TON, is just shy of the TONNE. On a crude approximation, they're roughly equal, but not quite. All right. Enough of density, unless there's another question. Pressure. Another thing that will show up when dealing with the solids, liquids, or gases is this force per unit area. A couple years ago, my daughter was taking chemistry here, and I was looking over her formal report, giving my feedback on it, and somewhere in there she wrote that pressure was a force. And I said, this is wrong. And she said, that's not what the book says. I said, show it to me. Thinking she must have misread it. And she flips to the glossary in the back of the book, and it says, pressure is a force. I said, no, that's not right. You should point that out to your teacher, that is not right. She was not inspired to do that. I did bring it up to the chemistry people, and they said, yeah, there are a couple of mistakes like that in there. Pressure is not a force. It is a force per area. So let's just do a quick example. How much pressure am I exerting on the floor right now? Well, the force that I'm applying, if I'm just standing here, so floor, me, I have my weight acting down, normal force is acting up. I'm exerting normal force on the ground, on the floor, and then I guess we have earth down here with the weight acting up. That is the force I'm exerting on the ground. If I'm just standing here in equilibrium, my weight and my normal force balance each other out, and so the force I'm applying is 956.32 newtons. That is the force I am applying. The area. Well, basically I'm standing on 2 feet here. So the question is, what's the area of my foot? Now some of my shoe is not touching the ground. This part up here sort of comes up a little bit. So it's basically from here down to there. Coming up with a crude measurement. So basically from around the ball of my foot to the end of the sort of my heel is about 26 centimeters. So I'm treating my foot like a rectangle. That's about 26 centimeters. The distance across, it's widest there, narrowest there, so it's probably averages somewhere around the same to the heel. That's about 8 centimeters. And I have 2 of them, don't forget that times 2. I have 2 feet. So what is the area? So I'm treating it like a rectangle. So You multiply them. Start 208.
Yes, for 1 foot.
416
For both feet. What are the units here?
centimeters,
Close.
cubic centimeters,
Not cubic,
meters squared.
squared. Yeah, well, you'll multiply 2 of them. Cubic, if we've done 3 of them. So square centimeters or centimeters squared. Not SI units though. We got newtons over here, we got centimeters over here. Let's get them both in terms of SI units. So we want this in meters. So what is this in terms of square meters? Sorry, yeah, square meters, that was right.
Is it gonna be 0.0416?
0.0416, yes it is. Now centimeters and meters is 2 decimal places, but we have 2 different centimeters we're converting here, because it's squared. So you move it over 2 and then another 2. So 0.0416 square meters. And we can now find the pressure that I'm exerting on the floor. Sorry, what is it?
I multiplied the two numbers, I got 22,988.
Oh, you divided?
Or, yeah, divided, I'm sorry.
So 22,000
988.46.
units?
Newtons over meter squared?
Yes. And Gary, was that what you were saying?
Mhm.
Okay. Newtons over square meters. Now, of course, there are occasionally the physicists or scientists get together and they go, you know what, I just hate writing newtons over square centimeters. Let's come up with a single unit. And so they did. So the derived unit, as it's called, for pressure would be 22,988.46 Pascal. Say Pascal. Anyone want to take a wild guess who it's named after? Yes.
It was a Disney joke.
Oh, sorry, I missed it. Thus, the hide and seek joke of Newton, Heisenberg, and Einstein were playing hide and seek. Einstein had his eyes closed, and Heisenberg went off to hide somewhere, and Newton stood right beside Einstein, and he drew a 1 meter by 1 meter square around them. Oh man, I blew the joke already. Try that again. Take 2. Pascal, Newton, and Einstein were playing hide and seek. Einstein closes his eyes, starts counting. Pascal goes running off. Newton puts a 1 by 1 meter square around him and stands right there in the middle of it. Einstein opens his eyes and says, ready or not, here I come. And he points at Newton and says, Newton, I got you. And Newton says, no, I'm a Newton over a square meter. You got Pascal. And we will end on that note. Yeah, physics jokes often are.